Hello. So I'm pleased to present to you our poster. MHD turbulence follows Kolmogorov scaling. You see a link to my webpage in the right, and two preprints in the left. So objective of this presentation is to test whether Kraichnan scaling or Kolmogorov-like phenomenology is valid for MHD turbulence. We also test critical balance and dynamic alignment hypothesis for anisotropic MHD turbulence. There are two leading theories for MHD. One is Iroshnikov-Kraichnan theory. Another one is phi-third theory. So there are many people who contributed to this phi-third theory. So we will examine these two theories using numerical simulations. So in Iroshnikov-Kraichnan theory, the spectrum is k minus phi-third is here. And additionally, the fluxes for z plus z minus variables. Please note that we use Alsacer variables, which is u plus b and u minus b. So these two fluxes, pi plus and pi minus, for these two variables, z plus and z minus, they're equal in Kraichnan-Iroshnikov theory. So this is one theory which was proposed in 1965. The second theory is phi-third theory. It has many proponents. Marsh, Goldrick-Sridhar, I had a paper on this also from renormalization group point of view. So this is the prediction phi-third. And in this theory, without getting into details because lack of time, so these fluxes pi plus and pi minus are not equal, unequal energy fluxes. Additionally, the structure function, third order structure function for these variables, z plus z minus, was shown by Pucci-Politano that it is proportional to L, which will lead to phi-third. Okay, so the structure function as well as the scaling arguments give you phi-third. Implicit assumption is that nonlinearity is strong for phi-third and is weak for 3/2. Now quickly, we find that we did simulations up to 1500 cube, and we found convergence with phi-third theory. So we found these two work. Now quickly onto anisotropic MHD turbulence. There are two predictions. One is phi-third again, and one is 3/2. Other one is 3/2. So Goldrick-Sridhar applied some arguments, and they argued that it is phi-third. Phi-third, and there's one critical balance relation: k parallel is k power 2/3. And here, dynamic alignment is theta L is 1/4. This is a length between U and B. It's angle between U and B. Now, we tested the spectrum. We found closer to phi-third. This is the spectrum here. Now, we examined the critical balance. We found that the k parallel versus k per relation, it is varying from 1. The exponent means k parallel is proportional to k per for b not equal to 0 naturally, but it goes from 1 to half, and it seems to saturate near half a large b naught. B naught is 10, so we used a pretty high b naught, which is 10. So critical balance, we are not finding it to be valid for large b naught. Also, we found that this scaling, we find that theta L is proportional to L to the power 0. Okay, this argument is a bit tricky, but is not dependent on is independent of L, which leads to phi-third. By the way, both of this theory leads to phi-third. And when we tested using the formula for Goldrick, we get 1/8. So we are finding overall that Kolmogorov theory is better model for MHD turbulence. Both isotropic and anisotropic. And there are some issues with the critical balance and dynamic alignment. So you can read our paper, which is here, and two papers are under review, which hope we will share with you soon. Thank you.